Okay, so once we have the inclusion separated and we can pick it out, we take the inclusion and very carefully move it onto a disc of sticky material. It's a double sticky carbon disc that we can use in the scanning electron microscope. It's just like a little tiny bright speck that you can barely see. And then we take that to the SEM and we're going to actually verify that it's an inclusion, that it's a sulfide. We want to see two things: that it's not a piece of the cracker, either tungsten carbide or steel, which it's so small at that point your eye can't really tell that it's a sulfide. Sulfides will look a little bit brassy or a little bit yellowish. But it's so small that your eye really can't detect, it can't pick up enough of that color to see what it is. You just see a bright object, a bright point. So we want to make sure it's not any of the metal, but we also would like to see if the sulfide is nickel rich and iron poorer, or it's iron rich and has a little bit of copper. And that would be the difference between an eclogitic or a protatitic inclusion. So if it's got the higher nickel, it would be protatitic. If it's got the lower nickel and higher iron, it would be eclogitic. And the reason we need to know that is when we go to do our chemistry, we're going to spike the solution that we're going to run with radiogenic, with what we call an osmium spike, not radiogenic osmium, but it's an osmium spike, so we can do the osmium isotopic the concentration. And there's about 1,000 times more osmium in a protatitic sulfide as an eclogitic sulfide. And so you need to use a different spike and a different spike amount if you have one versus the other. And if you use the wrong spike, you've kind of ruined the analysis. So we have to take it over the SEM and do a look at what it is. Plus, we also can see some very interesting textural features about the inclusion. We can see if we've got a fractured inclusion, whether we have the whole inclusion, whether we have exsolution, if there's interesting exsolution features. Look at the diamond, the morphology of how the diamond induced its morphology to the sulfide. And it's just an example of a point in this procedure where you can get extra information which might be useful in the long run. And so it's our only time to do it before we dissolve the inclusion. So that's why we put it on the sticky disc. And it will stay there until we're ready to do chemistry.